this is the data, almost like a day in a life, or what a data scientist does. So for the first thing that we try to do is we try to understand that we get a nature of a problem that we're working with the client. We work with the client, we try to understand what is the nature and the requirements of the problems that we're trying to do. So the first step is design and scope the problem out. After designing and scoping the problem, we got to frame the problem. So once we frame it, we take the appropriate data, whether it's from the client, whether it's from external sources. And this data could be anything about a customer to macroeconomic to microeconomic data to Twitter, Facebook, and whatnot. So all of this data, depending on the problem that we're trying to understand, we try to gather this data into a single place. And that is the second step of data science. Clean the data, get the data in the right format. After that, we model the data. This is the third segment of data science, which is, in other words, you're trying to, I do see a question. I'll answer the question right after. So we try to understand, once we understand the data, we try to build a model. How does the data look like? And we try to frame, given the problem that we're trying to solve, we try to frame a model that answers the problem that we're trying to solve. And I do hear. All right, let me answer that question about a data scientist technical abilities, and I'll get to that later. So then the last step after that is after we build the model, understanding that solves this problem that we framed, we try to evaluate our KPIs, meaning key performance indicators that we're trying to leverage. We try to increase and also validate and ensure that our models that we've built make sense. And all of this process gets reiterated, meaning we design the problem again, we frame the problem once more time, we rebuild, we ensure that we're meeting the KPIs from our clients, and it's almost like a never-ending cycle. And this as a whole seems very simple. We get a requirements from a client, we understand the problem, we model, we give it back to the client, and the client says no, and then we just keep going forward. Seems straightforward so far, but it's actually not so. All right, let me keep going. All right, so one of the first things I always say to people is data science is all about questioning, meaning we need to understand, as I said, we need to frame the problem. How do we actually frame the problem? We question what, who, what, why, and how. We try to understand and get deeper and deeper to precisely define the problem we're solving. In a case of, let's say, we're trying to understand whether a customer will come back to buy a vehicle. The question, the model, that before even building the model, we need to understand what is the type of data we require. So the questions would be, where do we get the data? How do we get the data? From where, from whom do we get the data? And that's the first step. And once we have gathered the data, we understand, does this data make sense? Why does it, if it makes sense, why does it make sense? Where, and so on and forth. And again, this is trying to understand the nature of the problem, defining the scope of the problem as well. And this goes into actually defining data sets as well. So this is the second step of, or the first step rather, of doing data science, is just to frame the problem and precisely understand the problem. Is there any questions about this?
I think you can go ahead at the moment, and we'll take Q&A later.
Okay, perfect.
Yep.
So the other thing that I always say is data science can't be done without a lot of data crafting and tap dancing. So once we frame the problem, we have to make the data into, like, we have to mold the data into something that's usable per se. So a lot of times this is actually a very tricky thing and an ugly thing about data science is the data that we get is never clean. Meaning there might be formatting issues. The data might not be able to understand it. It might have missing rows, missing columns, and so on and forth. This means we have to actually do a lot of time dancing to understand how to get the data into one place, sanitize it, clean it, and then once everything is done, we're ready to model. And again, this is not like the 3 pictures I have is like a person modeling, like actually a clay model. This is literally a lot of hard work. and dancing as well, because we're just doing a lot of things at once. And again, it's not a model as like a, you know, like it's a data science model per se. And actually, this in my opinion is the hardest part of data science, because a lot of times when we were working with clients, we have to chase people to understand that they get the data correctly. We have to wait for people to get the data, and once we get the data, we might not even have the data that we want. So this is almost like a never-ending cycle of getting the data and ensuring that we have the correct data, cleaning it, and asking for more data, and so on and forth. And this part, as I said, is, in my opinion, the hardest part, the data crafting. And this is in common terms, or today's, they call it data engineering. And this is a new segment that's coming up rapidly, and people need it. This is, in my opinion, a merge of engineering, data science, and it's a lot more of engineering, because you're trying to do building pipelines to actually understand how to clean, how to ingest, understand the data, and make sure the quality of the data is clean. Okay, let's keep going. So I kind of mentioned this earlier about how a data science is very circular. So once we have framed the problem and understood the problem, the thing that we try to do is basically build a model to solve this problem. So this means using a toolkit such as, I don't know to what extent people are technical. There's a lot of toolkits in Python. Python is a language in R, in Java, Scala, and whatnot. Any programming languages, they have a lot of toolkits to design machine learning algorithms. That basically you're picking an algorithm from the toolkit box and applying it on the data set. So we build a model that basically applies this on the data, and then we get a solution. And then obviously, I mentioned earlier, we will run into a lot of data access code. We will run into like basically a lot of code breaking, doors being logged late at night, meaning a lot of times the clients basically will say we won't be able to access, or they basically will deny the data. So it's almost like a never-ending cycle about getting the data. Once we have modeled from our toolkit, going back to the client and ensuring that we're meeting our the KPIs, metrics, and everything of that sort, and then coming back and just reiterating over and over and over again until we met the KPIs and are actually meeting our metrics to a good likelihood. And honestly, if we had infinite time, this would go on forever, because it's never, you can always do something better. So it takes a lot of determination, perseverance, teamwork, and persistence to do this data science, because we have to be very focused and diligent and understanding the data. We have to basically ensure, like, there's a lot of times things fail, so you have to keep on going. And it's just not you who's doing the job. There's a lot of teamwork, because you'll be interacting with the client, with your team members, and so on and forth. And persistence is key, because you never get it the first time right. You will never get it right. So again, on the side note, data science is a great methodology that can be applied for like Agile. And Scrum methodologies with data science is perfect. That's what we do at Cerebri. And since it's so iterative, it really fits in well. Let me keep on going. Okay, so another key thing in data science, in my perspective, is people skills. So this means basically, like, as I mentioned earlier, you'll be working with teams across various disciplines. Like, you'll be working with product managers, project managers, people who are in business. You'll be presenting your KPIs and metrics to key business folks. And so this requires a lot of interdisciplinary skills, at least the work that I do. And so that's one part. And also, as a data scientist, you will actually also, it'll be great to have skills such as project management, product management, business acumen, and something I call Chemical X. Or it's from Powerpuff Girls, if any of you guys have watched it. But basically, the reason I say project management is because when you're working, at least for us, when we were working with the client, you have to assign team members the appropriate amount of work, ensure that we were meeting deadlines, milestones, and so on and forth. Product management, in a sense, whatever you're delivering is a product. So you will have to know how to design problem design in a product way. And that's a very needed skill. And business acumen, in a sense of the whole thing about data science is improving your KPIs, making moolah for the clients, basically. So it requires an understanding of the business. That's actually a very key thing. The framing of the problem to designing the algorithms and so forth comes from understanding what is the business that we're trying to solve. What is the KPIs that we're trying to increase? And chemical X is this extra thing that everyone will need, because it's like a sense of like a confidence boost and so forth. Like this nature of it's a lot more than that as well. It's an that is, I don't know how to define. And along the way, there's also a lot of technical things that do happen, such as code reviews and design reviews. So whenever we're building any data science models to actually building frameworks, we will have a lot of code reviews and as well as design, ensuring the design that we're building of the framework is good. Once we build and implement the framework, is our code good? So this requires a lot of code reviews and not too much of software engineering, but having a software engineering skill would be very valid or valuable in data science. So let me keep going on. So this is a day in the life of a data scientist in essence. And this is specifically to me. So on my end, I actually meet with clients, understand their pain points, and show progress to our clients. So this is literally how my day starts. I go into work around 8 or 8:30, get on a call with the clients, and present what we've done, understand what they're liking, the features that we've built, what they do not like, try to understand when are they going to get, most likely is more 90% of the time is like, are they going to give us the data? When are they going to give the data? Is the data in a clean format? What is the format they're going to give? And then after that, I go into actually building these machine learning models. Again, so you're using just toolkits in certain languages like Python, Scala, R. And I validate these models and build KPI, ensuring that we're meeting the KPI metrics that we want to have. And then another thing that I usually do is engineer the data sets, meaning once we get the data from the clients, ensure the data is in our appropriate format, it's in the framework of the problem that we want, and so forth. And then obviously I meet with different teams and co-workers and have design and specific projects, advise on them on the projects. Lastly, actually a lot of this, as I said, building this engineering pipelines for understanding data quality and monitoring. So I meet with the data engineers per se, software engineers and data engineers about building pipelines and ensuring the design of that is actually going well. And we just talk through what are the solutions and if the logic is correct. So this is a day in the life of a data scientist at Cerebri. And this is actually a lot of companies that do data science across the world, in my opinion, especially if you're in a very high-paced community or a workplace. This is in essence what we do. Now let's keep going. So the one thing I do want to say is from what I've said so far, it seems that the data science is very technical. In my honest opinion, the technical skills come later. It's a lot about people, as I said, I mentioned earlier, it's a lot of people skills, understanding what the team wants, building the product out, ensuring, scoping out the client's work, defining the problem that we're trying to solve, and implementing the solutions. All these kind of tasks per se is more soft skills. In a lot of ways, you don't really have to build these models per se, as long as you're ensuring that these things happen and having a good in-depth knowledge in the technical aspects. That's sufficient. And if you're a person who's pragmatic and very, I guess, diligent in the way of doing things, that's one way of what I say is a data scientist. As a pragmatic designer who has soft skills, is delivery oriented, an ability to do various tasks at once. So this is a lot like a product manager as well. But this is a little more technical aspects of product management. And the other side is the technical researcher. Basically, this is in my opinion, the other side of things. This is if you're very involved into building out frameworks, setting up, if you want to implement state-of-the-art machine learning algorithms, and design and architect these, this is basically what you would fit into. And the skills that you would require for these are basically highly technical understanding of machine learning, data science, ability to think abstractly, and precise and focused, I guess, like being very diligent and single-minded on what you want to do. These are the two very varied areas of data science that I say, and you could fit anywhere in between. And honestly, like a data, in my honest perspective, it's just having the drive in anything that you do is more important than actually having a technical skill. And when I try to hire anybody, that's what I look for, is their ability to, say, I will do no matter whatever it happens, I'll get it done. That ability is very important, and ability to just get in the nitty-gritty details and getting stuff done is honestly the essence of data science.